All right, conserve, to save. So the energy is not created nor destroyed. So if I have 2 points, and it can be any 2 points along a journey, doesn't just have to be the top and the bottom of the hill, anywhere along there. If I take a snapshot, I am going to get a specific value for the energy. The kinetic and potential energy would change. Okay. As we're picking up speed, the kinetic energy is going to increase. As we're decreasing down the hill, the potential energy is going to decrease. How do we know this? By looking at the formulas. So a whole drawn out part, condition one, 1/2 m times the velocity initial squared plus mgh, and that's your height initially, is going to equal those same conditions at the end. Oftentimes, if you're rolling down the hill, then your height final would be 0, and your height initial would be how tall it is. That's if you're going down the hill. If you're going up the hill, then your initial height is 0, and your final height is the how tall the hill is. So just go slowly when you're putting in those numbers. The main thing to remember is at any point along the way, the energy is going to be a constant value. And most of these we're talking about no air resistance, no friction, because really we would have extra terms in there, and we would have to have some heat loss values in there for what was lost due to friction. But for most of these, we're just in year one going to consider that this is has all the information. What's cool about it is if it's frictionless, the mass is actually inconsequential and it is going to drop out. What is everything related to? Initial velocity, gravity, height. Final velocity, gravity, height. So those values are going to be what's dependent on finding your answers. The mass, not so much. So if you are doing the full out equation, your mass is going to cancel out. Just go slowly, because sometimes they just are going to talk about 1/2, in which case the mass does not drop out of just one side. So the energy at the bottom of the hill is 4,100 joules. That's the energy. That's your kinetic energy and your potential energy together. So in this case, it would be 1/2 mv squared plus mgh. Those mass values would have to stay here. If the initial velocity of the 10 kilogram boulder goes slowly, this is not the initial velocity. It's just squeezing in an extra term there. The initial velocity of the 10 kilogram boulder at the top of the hill, lots of details, is 5 meters per second. So we took a long time to get to the initial velocity. What is the height of the hill? Answer to the hundredths place. So most of the time I tell you it's okay just to do 1 decimal place. But if it tells you the hundredths place, make sure you're answering to 2 decimal places. The thousandths would be 3 decimal places. So just always read carefully. Same thing with the gravity, 9.8 or 10. Read carefully. So what do we know? The energy is 4,100. That means the kinetic energy plus the potential energy is always the constant value. So our kinetic energy plus our potential energy is equal to 400. It does not matter if this equation is for the start, the middle, or the end. It is always going to equal 4,100. So even though this is the energy at the bottom of the hill, and we want to know information about the top of the hill, it does not matter. I can still set that in there. I want to know the height of the hill. So I am going to be putting in my equation the velocity initial and the height initial, so that I can have an answer with a height in there. Okay, what do I know? 1/2 times the mass, which is 10, times the initial velocity squared, plus mass of 10, gravity 9.8, times height equals 4,100. Solve for the height to get that this hill is 40.56 meters tall. A bowling ball is attached to a 10-foot long cable. Okay, so we're probably going to have to convert that to meters, but let's wait and see. The cable is kept taut and the ball is raised to initial height of 0.95 meters above the classroom floor. It's released from rest and allowed to swing as a pendulum. Determine what its speed is when its height is 0.55 meters above the floor. So in this case, could we use a pendulum? Yes, we could, but I'm just going to go back to what I'm comfortable with because I've been using it since module 1. I am going to use my velocity final calculations because what in essence do I have going on here? Okay. I am going to have no force applied, no force of friction because I'm only dealing with stuff in the Y. There is no sum of the forces in the X in this case because I'm just talking about it at a snapshot. So I have a force of gravity going down and a force of normal, no force of normal, no surface. What is that? The force of tension going up. My force of gravity is going to equal to the force of tension if my acceleration is 0. We can't answer that quite yet. They want us to find the final velocity. So we probably are going to have an acceleration. Force of tension is my positive, force of gravity is my negative. That's equal to mass times acceleration. Okay. Now, when I look at that, I'm going, wait, I have no other information that is going to help me solve the problem. Okay, nothing to help me figure out that force of tension. Without figuring out what the acceleration is, and I don't have 2 velocities, so I can't figure out that. So then I go, scrap all this. Let me see what else do I have out there. What other information can I use? I can use conservation of energy. My kinetic energy and potential energy at the beginning is going to equal my kinetic energy and potential energy at the end. So I have all my conditions that were in red. It's going to equal my conditions in purple. So what does that equation look like? Here it is, 1/2 mv squared plus mgh equals 1/2 mv squared plus mdh. There is no mass given. Okay, so that messed me up on my free body diagram because I needed that to get further. But on this one, my masses can just cancel off. What is my velocity initial? It is released from rest. So my velocity for the first set of conditions is going to be 0. My gravity, does it say what to use? No, so I'm going to use 9.8. What is my height? What is my height? Now, I could put 0.95 for my height, and then at the other side, I could put 0.55, or I could just say, how tall is this actual part? 0.95 minus 0.55 is 0.4. You can do it either way. I'm just recreating the problem so it looks more like what we've seen before. The top and the bottom of the hill, and the difference that separates them is 0.4. Okay. After, I'm going to be solving for the velocity final. My g is 9.8 and my height here is 0. So my kinetic energy was 0 at the start. My potential energy is 0 at the end. So this is only one specific set of conditions where my potential energy at the start equals my kinetic energy at the end. That is not just like an always absolute. It only happens in these type of situations. So always write out the whole problem and then solve for your velocity final. Okay, and there is the answer there, so you can check it. You can also use the pendulum information. It's just going to take you a little bit longer to set up the problem than just sticking with what we know and using the conservation of energy. So I recommend keeping your formulas simple. Use the conservation of energy. Use module 1. Okay. 262 gram ball, that's my mass. That's probably going to need to be in kilograms if I actually need a mass, but I'm just going to put it there right now so I don't forget. Thrown at a speed of 42.5, so that's my initial, from the top of a hill. Determine the impact speeds. That's going to be the velocity final when it strikes the ground. Negligible air resistance, so that I know I can use my conservation of mass equations, etc. Drawing my free body diagram. What do I have going on here? Okay, I have no air resistance. I am only counting force applied at the instant it's thrown. So when I'm doing this free body diagram, I don't have a force applied. Air resistance is 0. I don't have a force of friction. It's not on the ground yet. I don't have a normal force. So I just have that force of gravity helping me go down. Force of gravity equals mass times acceleration. Mass times gravity equals mass times acceleration. My acceleration is due to gravity. Okay, so that kind of makes sense. So I can use my module 1 equation here with my gravity. Okay, or I could use my conservation of energy. Fill in all of them and see, oh, this one's easier to solve for, then do that. There's often multiple ways to solve the problem. So in these sessions, I'm really trying to get you to set up as many problems as you can, multiple ways, so you get into a rhythm of, oh, this is what works best for me. Okay, so we have velocity final, that's what we're solving for. Velocity initial, 42.5. Gravity, 9.8. Distance, 43.5. So could we solve for velocity final? Absolutely. What about the one on the bottom? Could I put in the masses? I could, but look at this. I could also cancel out all those masses. Velocity initial, 42.5. Gravity, 9.8. Height, 43.5. Velocity final. And then that height final here is 0. That one, in this case, I would not want to do conservation of mass. Why? All those 1/2, I'm going to end up typing it or missing one of those when I plug it into the calculator because I make mistakes. Okay, so I would use that top equation for this one. So same exact problem we did in module 1, honestly. Okay, and there is your item to check your answer. Please do make sure you do the ungraded ones first. There's a lot of little questions in there so they can help you practice. There's a practice quiz on this one. There's all sorts of stuff in there. So don't forget to use that to help you out. And that's all for today.